All right, hold on to your neural networks because DeepMind just dropped something that's making me question reality. They've created an AI that can solve math problems at a level that would make most PhD students weep into their coffee. We're talking about problems that have stumped mathematicians for decades, and this thing is cranking through them like a calculator on steroids.
Wait, we're talking about the alpha-proof system, right? Because I saw the initial reports and honestly thought it was too good to be true.
That's exactly what I'm talking about. And the kicker? It just won a gold medal at the International Mathematical Olympiad. Not participated, not did okay. Won gold. Plus, we've got some wild developments in AI safety that actually have me cautiously optimistic, and a robotics breakthrough that's straight out of a sci-fi movie. I'm Thomas.
And I'm Aiva. Welcome back to Semper AI Digest. Thomas, before you get too carried away with the math genius robot, can we talk about what this actually means? Because mathematical reasoning has been like the holy grail for AI systems.
Oh, absolutely. So DeepMind officially announced AlphaProof yesterday, and this isn't just another incremental improvement. Think of it this way. If previous AI math systems were like really good calculators, AlphaProof is like having Archimedes, Newton, and Einstein sitting at your kitchen table, working through problems together.
Okay, that's a vivid analogy, but let's get specific. What kinds of problems are we talking about here?
Right. So the International Mathematical Olympiad problems aren't your typical algebra homework. These are the problems that make math professors go, let me think about this for a few hours. They require creative leaps, novel proof strategies, and the kind of abstract reasoning that we've always thought was uniquely human.
And AlphaProof solved 4 out of 6 problems correctly, which was enough for a gold medal threshold. But here's what's really interesting to me. It's not just that it got the right answers. According to DeepMind's technical report, it's generating novel proof strategies that human mathematicians are calling elegant.
Exactly. And this is where it gets really wild. The system isn't just brute forcing its way through these problems. It's using what DeepMind calls formal reasoning, where it constructs step-by-step logical proofs that can be verified mathematically. It's like the difference between guessing the answer and showing your work in the most rigorous way possible.
Can I jump in here? Because I think there's a broader implication that people might be missing. Mathematical reasoning isn't just about math. It's fundamental to scientific discovery, engineering, economics, even legal reasoning. If we've cracked this,
Oh man, you're absolutely right. This could be the breakthrough that unlocks AI's ability to do genuine research and discovery. Imagine an AI that can work through the kind of complex proofs needed for materials science, or economic modeling, or even theoretical physics.
though I do want to pump the brakes just a tiny bit here. The problems AlphaProof solved were incredibly difficult, but they were still within the domain of competition mathematics. Real-world mathematical research often involves much messier, more open-ended problems.
Fair point. But here's what has me really excited: the methodology. DeepMind trained this system using something called reinforcement learning from formal proofs. Essentially, they taught it to think like a mathematician by having it practice on thousands of formal mathematical proofs, learning not just what the right answer is, but what constitutes valid mathematical reasoning.
And that's actually a huge deal because formal verification is bulletproof. When AlphaProof generates a proof, it can be checked mechanically for correctness. There's no ambiguity, no, well, it seems right. Either the logic holds or it doesn't.
Exactly. And get this, they're already seeing applications beyond pure mathematics. Early reports suggest the system is being tested on optimization problems in logistics and resource allocation. Imagine having an AI that can prove mathematically optimal solutions to supply chain problems or energy distribution.
That actually brings up something interesting. How does this compare to what we've seen from other labs? Because OpenAI's been working on mathematical reasoning with GPT-4, and Anthropic has talked about formal reasoning capabilities.
Great question. From what I can tell, this is a significant leap beyond what we've seen from the major language model providers. GPT-4 can solve a lot of math problems, but it's more like having a really smart tutor who might make occasional errors. Alpha proof is more like having a mathematical proof-checking machine that happens to be incredibly creative.
And the timing is interesting too. We're seeing this push toward more rigorous, verifiable AI reasoning, right as concerns about AI safety and reliability are reaching a fever pitch. It's almost like DeepMind is saying, here's how we build AI systems we can actually trust.
Oh, that's a perfect segue, because our next story is directly related to that. We're seeing some genuinely promising developments in AI safety research, and for once, I'm not talking about theoretical frameworks or position papers. We've got actual working systems.
Are you talking about the constitutional AI breakthrough from Anthropic? Because that one has me cautiously optimistic for the first time in a while.
That's exactly it. So Anthropic published their results on Tuesday, showing that their new constitutional AI approach has reduced harmful outputs by over 90% while actually improving performance on helpful tasks. It's like they figured out how to make AI both safer and smarter at the same time.
And crucially, this isn't just internal testing. They've released evaluation frameworks that other research groups can use to verify these results. The transparency is refreshing.
Right. So let me paint the picture here. Traditional AI safety has been like trying to child-proof your house by just telling the kid not to touch anything dangerous. Constitutional AI is more like redesigning the house so that even if the kid explores everywhere, they can't actually get hurt.
That's actually not a bad analogy. The system learns a set of principles, they call it a constitution, and then uses those principles to evaluate and modify its own outputs in real time. So instead of just training it to avoid bad outputs, it learns to reason about why certain outputs might be problematic.
And here's the really clever part. The constitutional principles aren't just hard-coded rules. The system can engage in what they call constitutional reasoning, where it works through the ethical implications of potential responses before generating them.
Which addresses one of my biggest concerns about AI safety measures, which is that they often make systems less useful. You know, the dreaded, I can't help you with that response to perfectly reasonable questions. But according to Anthropic's benchmarks, this approach actually improved helpfulness scores.
Exactly. And they've been pretty open about their methodology, which gives me hope that this isn't just clever prompt engineering or evaluation gaming. They're training models to internalize ethical reasoning in a way that generalizes to novel situations.
Though I do want to be careful about overselling this. The evaluation was primarily done in English on text-based tasks with scenarios that are probably pretty similar to what the system was trained on. Real-world deployment is going to be messier.
Absolutely fair. But here's what has me excited. Other research groups are already building on this work. I saw preliminary results from researchers at Stanford who are applying constitutional principles to multimodal AI systems, and early results look promising.
And the timing is crucial here. We're at this inflection point where AI capabilities are advancing so rapidly that safety research has been struggling to keep up. Having practical, deployable safety improvements gives me hope that we can actually scale these systems responsibly.
Right. And it's not just Anthropic. We're seeing similar approaches from other labs. OpenAI's been working on what they call process supervision for their reasoning systems, and even some of the smaller AI companies are prioritizing safety research in ways we haven't seen before.
What's your take on why we're suddenly seeing this surge in practical safety research? Because for years, it felt like safety was this theoretical field that was always promising results soon.
I think it's partly because the stakes are finally clear to everyone involved. When you've got AI systems that can potentially solve mathematical proofs that stump experts, or generate code that could run critical infrastructure, the safety question isn't academic anymore. It's urgent and practical.
And frankly, I think the market is demanding it too. Enterprise customers aren't going to deploy AI systems at scale if they can't trust them to behave predictably. So there's real business incentive to solve these problems.
Which brings us to something that might sound like science fiction, but is apparently happening right now. Boston Dynamics just demonstrated a humanoid robot that can perform complex manual tasks with human-level dexterity. And I'm not talking about picking up boxes or opening doors.
Wait, are you talking about the Atlas demonstration they posted yesterday? Because I watched that video 3 times and I'm still not entirely sure what I saw was real.
That's the one. So picture this. They've got their Atlas humanoid robot assembling electronic components, threading needles, and even performing what looks like surgical suturing with precision that would make a surgeon jealous.
And crucially, this isn't a carefully controlled lab environment. They're showing the robot adapting to unexpected situations in real time. At one point, someone moves the work surface while the robot is working, and it just adjusts seamlessly.
The hand dexterity alone is mind-blowing. For decades, robotics has been limited by what engineers call the manipulation problem, getting robots to interact with objects the way humans do. These new demonstrations suggest that barrier might finally be cracking.
And the AI integration is what makes this really significant. This isn't just better hardware. Though the hardware improvements are impressive, the robot is using real-time visual processing and motor planning that lets it adapt to novel situations on the fly.
Right. So they're combining computer vision, tactile sensing, and motor control in ways that create genuinely emergent behaviors. The robot can figure out how to manipulate objects it's never seen before, using principles it learned from previous tasks.
Which has enormous implications for manufacturing, healthcare, domestic assistance, really any field where you need precise manipulation in unstructured environments. Though I have to ask, how close are we to actually seeing these capabilities deployed?
That's the million-dollar question. Boston Dynamics says they're beginning pilot programs with manufacturing partners later this year, but I suspect we're still a few years away from seeing these robots working alongside humans in most environments.
And there are still significant challenges around safety and reliability. A robot that can suture wounds can also cause serious harm if something goes wrong. The safety validation for these systems is going to be incredibly rigorous.
Absolutely. Though it's worth noting that they're approaching this thoughtfully. The pilot programs are apparently starting with controlled industrial environments where the robots work in separate areas from humans, gradually expanding to more collaborative scenarios as the technology proves itself.
Which seems like a smart approach, and honestly, seeing this level of physical capability emerging at the same time as the advances in mathematical reasoning and AI safety feels like we might be approaching a real inflection point in AI capabilities.
Totally agree. And speaking of inflections, we've got some rapid-fire updates that are worth hitting before we wrap up. Meta just announced their new Llama 3.2 models are showing significant improvements in code generation and reasoning.
According to their benchmarks, the largest Llama 3.2 model is performing competitively with GPT-4 on several coding benchmarks, which is impressive for an open-source model, though I'd love to see some independent evaluation before getting too excited.
Fair point. And NVIDIA announced new AI chips specifically designed for edge deployment. They're claiming 10x better performance per watt compared to their current generation, which could make sophisticated AI accessible in much smaller devices.
That's huge for mobile applications and IoT devices. Imagine having GPT-4-level capabilities running locally on your phone or in your car. The privacy and latency implications alone are worth paying attention to.
And in a move that surprised absolutely no one, Google announced they're integrating more advanced AI capabilities into Google Workspace. Docs, Sheets, and Gmail are getting what they call reasoning-aware assistants that can understand complex multi-step requests.
Which sounds useful in theory, though I remain skeptical about how well these integrated AI features actually work in practice. Google has a track record of over-promising on AI integration.
Though early user reports seem more positive than usual, we'll see how it holds up with broader deployment. And speaking of deployment, OpenAI quietly updated GPT-4's knowledge cutoff to include information through March 2026, which suggests their training and updating processes are becoming much more efficient.
That's actually significant, because one of the major limitations of large language models has been stale training data. If they can update knowledge more frequently without full retraining, that removes a major barrier to practical deployment.
And our final quick hit. researchers at MIT published results showing that AI systems can now predict protein folding with accuracy that rivals AlphaFold, but using 100x less computational resources. Could be a game changer for drug discovery research.
Which brings us full circle to the mathematical reasoning breakthrough we started with. It feels like we're seeing advances across multiple domains that all point toward AI systems becoming genuinely useful for scientific research and discovery.
Exactly. And what has me really excited is that these aren't just incremental improvements. We're seeing qualitative leaps in capabilities that open up entirely new applications. The alpha-proof mathematical reasoning, the constitutional AI safety improvements, the robotic dexterity advances. Each of these feels like a piece of the puzzle clicking into place.
Though I think it's worth remembering that impressive demonstrations and real-world deployment are still very different things. We're definitely in an exciting phase, but the practical timeline for seeing these capabilities widely deployed is probably longer than the hype cycle suggests.
Absolutely true. But I think what's different now is that we're seeing multiple research labs tackling the reliability and safety challenges alongside the capability advances. That gives me confidence that when these technologies do deploy widely, they'll actually work as advertised.
And the level of transparency and reproducibility we're seeing is encouraging. The fact that DeepMind published detailed methodology for AlphaProof, that Anthropic is sharing evaluation frameworks for constitutional AI, that Boston Dynamics is being realistic about deployment timelines. It feels like the field is maturing.
I couldn't agree more. We're moving from the era of trust us, this is amazing, to actually showing the work and letting other researchers verify and build on these results. That's how real scientific progress happens.
So where do you think we'll be a year from now? Because if the pace of progress continues, I'm not sure I can even imagine what we'll be talking about in April 2027.
Honestly, I think we'll be talking about AI systems that are genuinely collaborating with human researchers on solving real scientific problems, not just assisting or augmenting human work, but actually contributing novel insights and discoveries. The mathematical reasoning breakthroughs suggest we're close to that kind of capability.
And I think we'll see the first real deployments of highly capable humanoid robots in controlled environments. Not widespread adoption, but enough real-world testing to validate whether these impressive demonstrations translate to practical applications.
Plus, I suspect we'll see major improvements in AI safety and reliability that make enterprise adoption much more widespread. If constitutional AI and similar approaches prove out at scale, that removes one of the biggest barriers to deploying AI in critical applications.
Which would be genuinely transformative. We've been in this phase where AI capabilities are impressive in demos, but still too unpredictable for high-stakes applications. Breaking through that barrier changes everything.
Exactly. And I think that's what makes this particular moment so exciting. We're not just seeing impressive party tricks anymore. We're seeing the foundations being laid for AI systems that could genuinely accelerate human knowledge and capability in profound ways.
Though, as always, we'll be watching carefully to make sure the reality lives up to the promise. That's what we're here for, cutting through the hype to understand what's actually happening and what it means for all of us.
Speaking of which, if you found today's deep dive useful, make sure to subscribe to Semper AI Digest so you don't miss our coverage as these stories develop. We'll be tracking the real-world deployment of these technologies and separating the genuine breakthroughs from the marketing hype.
And share this episode with anyone who's trying to keep up with the pace of AI development. We know it can feel overwhelming, but that's exactly why we're here, to help you understand not just what's happening, but why it matters.
Until next time, keep your algorithms sharp and your skepticism sharper. This is Tomas.
And Aiva, reminding you that the future is being built right now, and we're here to help you understand it. Thanks for listening to Semper AI Digest.